And who knows what's coming, out of the Arctic. I'm finally going to transition to maybe what you did yesterday, just the changing Arctic again and just
Although
going
it
from
snowed here last night.
Oh my God. And that's strange, right? A
April's
little
supposed
bit?
to be the driest month in the interior Alaska, and this April has been anything but dry. It's been wet.
Oh my God. I mean, it's just the little things, but that's definitely a sign, right? Everything's still out of whack.
Yep.
The warming in the Arctic. It's a new Arctic, right? The whole Arctic holds in the permafrost thaw you were talking about. I have my notes.
Yep. And a whole bunch of people posting these videos. The heat bomb that's going into the Arctic. There's a heat bomb in the Arctic. This and the other thing. Well, I figured that out 10 years ago. This is
Seriously.
not. This is not new. And who the base saying, "Oh, you got all this warm water, coming in through the Bering Strait and Fram Strait." Well, of course, you got water flowing from lower latitudes. You got the oceans are heating. Of course, there's going to be warmer water flowing in. In fact, I had actually decided, I'm still working on an ocean heat content video
Yes.
because I ran into a major problem with my software. It like totally botched. I had to redo it all. It just totally
No.
everything up. I was ready to 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 test the hypothesis if my computer could fly. But anyway.
Seriously, Jim, I know where you're at. I know. It's too much.
but, but so a lot of questions I always get because
Oh man.
you've heard me in my videos saying that the ice is melting earlier because you have the heat and this and the other thing, and people have asked me, and it's a perfectly legitimate question, goes, how can that be if you don't have the sunlight energy or the sun energy, the angle is really low? Perfectly legitimate question. And I was thinking about this as, I'll just talk about the flow of the heat, especially after seeing that data with the ocean heat content. I said, well, there's your answer. They said, well, I'll discuss the flow, the circulatory flow into the Arctic, part of what I used to do, right? And I'll talk about water moving in through the Bering Strait from the Pacific side, through the Fram Strait from the Atlantic side, the warm. But what I want to do specifically is not just say, yeah, it's moving in. I want to, and I'm working on the calculation now. I want to calculate how many sphere drips of water is moving in. A sphere drip is 1 million cubic meters per second. So I want to calculate what that flow is and what the heat content is, so you get a quantifiable idea of the amount of heat energy that's moving into the Arctic. And then, of course, it
Wow.
moves in there and the heat starts diffusing up, so it starts melting the ice from below. So I had this in mind, and then I see these articles come out, and I'm like saying, yeah, well, I knew that. It's just like, it's no big surprise here.
Oh my gosh. You were ahead of
It's
it.
just, so, but see, and then there's another thread that was being passed around, and again, it's frustrating. You're seeing more and more of this. Well, if we went to zero emissions, we can keep the warming to under 2.
Mm-hmm.
Because the oceans are going to keep absorbing the heat for us. No, they're not. You need, as long as there's a thermohaline flow, yes, you can sequester heat from the surface to depth. But you know what? The thermohaline is slowing down and the oceans are getting really stratified. That's what I'm going to stress in my ocean heat content when I put up this one graphic and we go, there it is, folks. This is what the ocean is right now. And
Okay.
and basically, I gotta edit it now,
No.
but it's just that the oceans are warming up so much that they can only absorb so much heat. And don't forget, you're going to have thermal expansion, all that kind of stuff. And even if they could absorb the heat ad nauseum, they're also absorbing CO2. But as it gets warmer and warmer, gas solubility decreases with an increase in water temperature. So at some point, CO2 saturation will be reached. And the data I'm looking at is indicating that it may be getting there.
Okay.
And when the CO2 saturation is reached, and then the warming continues past saturation, you know what happens to the CO2 that's in solution?
What happened?
goes back into the atmosphere. It outgasses. So now
For
you
sure.
increase the CO2 in the atmosphere. And we know what CO2 and temperature relationship is all about.
So essentially, it's its own factory. It becomes its own factory of emissions.
These people keep thinking
Excuse me.
atmospheric. They keep thinking the ocean is just a sewer, a dump. They don't understand the role of the ocean in everything, in climate especially. And then when you consider the specific heat content of water versus air, yeah, it's a huge amount of energy differential. And they never take this into account. And it's an erroneous assumption.
And the oceans have been at their warmest, I'm assuming, in
The
our life,
oceans, I mean, we're talking about the atmosphere warming 1.4, 1.5 now. The oceans have also warmed by 1 C.
okay.
And think about the specific heat. It if I have say a cubic meter of air and a cubic meter of water, okay, and I add heat energy to both, the same amount of heat energy, okay, because air has a much lower specific heat, it takes far less energy to increase the temperature 1 degree C. Go to the cubic meter of water, it takes considerably more energy to warm that up 1 degree C. So
Oh,
if the oceans have warmed up 1 degree C, which is basically 2/3 of what the atmosphere has warmed up, think of how much energy the oceans have absorbed, how much heat energy. I can give you a number.
okay.
The oceans have absorbed 93% of all heat energy emissions since 1971. So in the last 40 or 50 years, the oceans have absorbed 93% of what we put out.
That's amazing.
So right now, the oceans are saving our asses for the moment, but this can't go on because
No.
physics, physics tells, you just have, people just need to understand basic concepts of physics, and basic principles. It's, there's a saturation level that gets reached.
And we're basically there. I mean, this is
We're
amazing
approaching it.
information. The
We're
whole,
approaching it.
yeah, so the whole like idea of like the net zero issue, we'll get to net zero by 2040, right? And that's, you know,
My response to people who say that we can get to net zero, this and the other thing, or my response is please share whatever foliage you are smoking
yeah,
because it's
it's
not realistic. Well, first of all, okay, let's look at it this way. Okay, you want green technology. Okay, laudable goals, laudable aims, but to get the materials, the raw materials to make the stuff, a battery, a solar panel, a big windmill, whatever. You have to do what? You have to go mining. And mining does what? You have to bring in big equipment. What do big equipment run on? Diesel.
yeah.
So, yes, now this is where when we discussed this before, you have to look at the budget. What's the input, the output, that kind of stuff. So, yes, maybe overall you have a reduction in greenhouse gas emission, but it doesn't go to zero.
No.
That's the point. Everyone says, "Oh, go to zero." It does not go to zero, and even if it did, it won't. But let's humor them. Let's say it did. You still got methane leaking out of the permafrost.
Yeah, it's a runaway
You
system.
got capped. You got capped natural gas wellheads. They're still leaking methane, even though they're capped off. And here's the other thing with the warming ocean. Well, just like if you warm the atmosphere, you thaw out the permafrost in the ground, right? You're warming the oceans. You have the seafloor substrate. You're doing what? You're helping to thaw out the clathrates, melt the hydrates, and methane gets released.
Oh my God. It's a factory. It's an out of
And
control
that's
system.
what's happening. We are we're now seeing a rapid increase in methane releases from the seafloor bed. We're measuring it now.
Methane releases from the seafloor bed. Holy Toledo.
And don't forget, methane gets into the atmosphere. Yes, it's a more potent greenhouse gas than CO2. Well, it doesn't last long, so its effects will diminish. No, because methane oxidizes into carbon dioxide.
Just further warming the planet beyond
So the
comprehension.
effects will continue. The effects will continue, which is why you're seeing more and more, instead of saying, oh, we're at 421 ppm of CO2, you're now seeing CO2 equivalents in parts per million because the methane and the nitrous oxide adding to that as well. And now if you look at the ppm equivalents of CO2, it's like 560, 570.
Okay. Yeah, it's like an underrepresentation all the time.
Yes.
Okay.
Yes. So
Holy fuck. I mean, we were just at 420, but really it's probably 560.
when you factor in methane and nitrous oxide.
I always get my mind blown because it's just too much. It's just too much. It's a recipe for disaster.
Mm-hmm.
We're seeing it. I mean, yeah, go ahead.
We're on our way to, we're like half, the rate we're going between, take your pick, between 2040 and 2100, we'll be halfway to the PETM levels of CO2.
Oh my God.
But here's the thing, ecologists is basically saying that an increase of 4C, humans go extinct. So we're talking about 7C, 9C, 11C by 2100. We'll be moved, we'll be dead.
But we see it in slow motion, like that's the point, when we're like warning people, but
it may be slow motion to us because of the perspective of the human lifespan, but taken into conjunction with the 4.5 billion year Earth history, this is not even a nano fart.
It's amazing. It really is just the scale and what has happened and what is going to happen.
It's the scale, and the thing I try to stress in my presentations is the rate of change. It's the fastest for which we have data for by far, and then to construct your budgets, your inputs, your output, what's a source, what's a sink. That's what you have to do. And when you construct the budget, most things are turning into sources, not sinks.
Yeah, and that's
Right
the
now, the
problem.
oceans are a carbon sink, but eventually the oceans will turn into a carbon source. And when that happens, bend over, stick your head between your ass, and kiss it goodbye.
Game over. No
Game
more
over.
lives. That's it.
I mean,
Shut
you
down
take
the
someone
system.
like
Oh
you
my
take someone
God.
like Michael Mann, who's going on this, oh, you climate doomers, and
Oh no.
we can keep things under 2. It's like, Michael, you know better than that. And then you contrast him with what James Hansen has said, and he's basically saying, we're fucked.
Yeah. I mean, it's so hard. Like you said, like just the human lifespan day to day, not much, but the signs are there, but just, the time scale of space and time, this is just a blip and will be a blip because of what, has happened to the human species, unfortunately.
It is. And,
Yeah.
I mean, planet Earth will continue on. We'll have a
Right.
mass extinction. System will recover, do what it does, and
Yes.
the Malanka and so on. And then you have new species evolving to fill the vacant niches.
Yes.
Planet Earth will continue, and then maybe we'll be visited by aliens going through a wormhole, and it'll come upon and basically saying, well, I guess there used to be a civilization here.